Alright, hello everyone. Here's our assignment for today. We have 10 problems using the double identity formula. We have the solutions over here, information, and here we go. I'm going to do problems 1, 2, and 3 for you, and I'm going to do them on this sheet of paper here. So here we go. Problem number 1. Remember our double identity formulas. Sine, cosine, we have 3. Tangent, we have 2. Problem number 1. First thing we always want to do is figure out what this angle is. Tangent of theta is 3/4. Well, 3/4 could be here or here, but it's in this quadrant down here, 180 to 270. So it's down here. Draw the triangle. Opposite over adjacent is tangent. So there's our triangle that we're doing. This is theta right here. And our job is to find the double angle sine of theta. Well, we know what sine is. Sine is -3/5, and we could just times it by 2, but that's not going to get us there. You have to use this formula. So it's 2 times the sine, which would be -3/5, and times the, let's see, cosine. Cosine would be -4/5. And a lot of fraction work. Try and reduce. Is there anything top and bottom that divide out? No. Multiply straight across. 24/25. You will find that answer on the answer box. Problem number 2. Let's see here. Do I have it? Sine's 5/13. Alright, let's go ahead and draw this angle. 0 to 90. It's in this quadrant here, quadrant 1, and it's 5/13. So that's that skinny triangle there. 5/13 and 12. You're going to get really good at your Pythagorean triple. So there's our triangle. And we're asked to find tangent of 2 theta. So we can't just times it by 2. We have to use this formula. We could use the top one and the bottom one, but I don't know the sine and cosine of a double angle, because that'd be those formulas, so I'm going to have to use this top one. Let's see here. 2 times the tangent value, which would be 5/12, over 1 minus the tangent squared, so that would be 1 over 25 1/44. And again, this is a good answer. It's not in the right form, so we want to simplify stuff down. You'll be really good at fractions after this. Let's see here. I could get that to be 10/12, but why not divide that out right there by 2? Divide this by 2 is 1, divide that by 2 is 6. 5, 6 in the numerator. In the denominator, 1 whole is 144. 144. Subtract across, I got 119 out of 144. Complex fractions, multiply top and bottom by the least common multiple. In this case is 144. Gone, gone. It's 119. And these divide out, and that makes, let's see, 24. 6 goes in there 24 times. Multiply the top, 120 19ths. A lot of work with fractions. For a quiz coming up, if we have large numbers, you'll use fractions. If we have small numbers, we won't use, or if we have large numbers, we use calculators. If we have small numbers, we won't use calculators. Number 3, tangent of √7/3. So we have some Pythagorean theorem stuff going on here. Let's see here. It's in the quadrant between pi and 3π/2, so it's down here. And the opposite side is √7, and this side is 3, but again they're negatives. And if you want to figure out what this side would be, it'd be a squared, which would be 9. 9 plus b squared would be 7 equals c squared, that's 16. Well, obviously c is 4. So this is a -3/4 √7. Not to be confused with the first triangle, which is a 3, 4, 5 hypotenuse. This hypotenuse is only 4, so don't stick. It'd be real easy to stick a 5 over here, but it's not. It's 3, 4, -√7. Alright, we have to do the cosine 2 theta. Well, that's where we take cosine squared minus sine squared. That formula is up at the top. Cosine would be a -3/4. Adjacent over hypotenuse squared minus sine, which would be a -√7 over that same 4 squared, and this would be 9/16, 7/16. comes out real nice to 2/16, which is 1/8, and you will find that on your answer sheet. Alright, this should get you started on the assignment. Again, just draw the picture, use the correct formula, be careful with your fractions.